Welcome back to another glorious sunny day in Thailand. A couple of days ago I took a long walk down our beach, 6 kilometers of nice white sandy beach, past tanning tourists of all sizes. Got to the end, had a nice shrimp afternoon snack and walked all the way back. Man, were my legs tired at the end. But now we're going to dive back into differential voltage reading and see what a mess I can make out of this. Because I've got to make changes because of the domino effect of other changes I've been forced to make on the board because of the scarcity of pin availability on the C21 chip. Okay, before I start hacking up the circuit board, I want to outline what I'm going to do in Atmel START. We're on ADC 0 to measure voltage, differentially between two selected pins. The old initial design I had on pins 5 and 6, which maps to PA0 4 and 5, which maps to analog input 4 and 5. I'm changing to analog pin or AN 0 and 1, which maps to PA0 2 and 3, which maps to pin 3 and 4. So let's see if we can get Atmel START to agree that this is a good idea. Okay, I've gone in and I've added an ADC 0. So let's scroll down and select its configuration options. First thing we want is asynchronous mode, of course. Instance ADC 0, yes. We will be dealing with analog input 0 and 1, which map to PA2 and PA3. Scroll down a little bit more. 12 bits, yes. I want to be reading against the analog power rail. Peripheral clock, that's okay. Differential mode, yes. And our positive mux is ADC 0. Yes, AIN 0. And the negative mux is AIN1. And I'll have to remember that when I do the wiring. So let's go ahead and we'll do a save. We'll generate all the other code and then go in and update the code in my main. Okay, you can see that I've updated this description block for the voltage sensor in my comments. You gotta comment everything. I know programmers hate putting comments in the code, but I can't live without it. There's no way that without defining all of these things that I could know where I stand and try and recreate things or debug things or change settings. So that's vitally important that you keep your comments up to date. And the key thing is we're back on ADC 0 for voltage, differential mode, and we're on analog input 0 and 1, which is PA0 and 2. And here I initialize the analog to digital converter subsystems. First ADC 0 for voltage, and then ADC 1 for current. I register the callback. They each have their own callback methods. This is ADC voltage sensor callback and ADC current sensor callback. And then I enable the channels ADC 0, ADC 1, and this right here is supposed to be the channel number. But as far as I can tell, in ASF4, the framework that all of this is running in, it only understands that there's one and only one of these physical channels per chip in the Atmel family. Now, so don't ever try and use more than one channel when you're dealing with these chips, unless in the future they come out with something that supports multiple channels per ADC. One enhancement that I've added, instead of blindly calling for an analog read in my loop method down below, I'm using the timer feature of the chip, which seems to be quite good and quite extensive. And I've set up a timer for analog to digital calls, and right now it's set up to fire every 1,000 milliseconds. So every millisecond the hardware is going to tick, and it's going to take an analog reading from both the voltage and current sensors. This is the callback for the timer that I've got set up for the analog to digital converter. Whenever it fires, I straightforwardly come in and initiate a conversion on ADC 0 and then ADC 1, and I release back to the system. So I'm not holding anything up while the read from the analog input pins is ongoing. And here's the meat of the system. This is the callback method whenever a reading of the voltage sensor completes. We call ADC async read channel because the results have been collected by hardware, and this call simply copies the values into this 2-byte buffer from ADC 0 for voltage. And then I've got some old code in here that I don't want to delete, but so I've got it all current commented out. Then I take that value, those 2 bytes, and I pass them to a helper method called convert raw voltage sensor value to volts. So calling this goes from raw hardware to fully converted and calibrated voltage reading. And I write to this value, which is the global value for the volts in the system. This is declared volatile, which the compiler knows to make sure that anytime a value tries to write or read this, it does so atomically. It doesn't try and cache it. It explicitly reads and writes it as you would expect without the system taking any shortcuts. So this is always guaranteed to hold the last current valid value. And that pretty much mimics exactly what I've got going on for the current sensor callback. Convert raw current sensor value to amps, 2 bytes, and I get back the complete calculated and calibrated amps. Now here is my helper method. What it does is the voltage, the resistor divider will take a voltage from 0 volts to the maximum defined by the resistor divider, say in my case maybe 84 volts. And that takes that raw input value from the hardware after it gets divided down by the resistor network, and it gets mapped to a 0 to 5 volt number. I take that 0 to 5 volt number and I convert it to volts. First I convert it to from kind of computer form to a workable number. I then calculate the voltage is the ratio of the sensor input to full scale. So everything is a 12-bit number here. So the full scale would be 4096. If the input pin read 4096, we would be exactly 5 volts. But it's going to be less than 4096. So I do a ratio of the input number to 4096. Then I multiply that by the sensor maximum value that the user has entered through the menu system, which essentially scales the user's maximum value, say 84 volts, against the input reading, and that's my voltage. Now, that's still raw because I then apply the offset and the slope of the calibration function that I'm going to get the user to do, and then that is my completed voltage reading, which is then ready for the next CANbus write to the bus. Okay, we're back after board surgery and more messing around that I thought was humanly possible. But let's see, we've got 11.64 volts on the input, and my voltage divider circuit should be delivering 0.535 volts to the analog input pins. But when I first hooked this all up, I was only getting about half of that, about 0.27 volts. And after in more messing around, I found that this capacitor, which had been recommended to put across the input pins in the schematic, which I'll paste in right here, was cutting my voltage in half. and not doing its job as a smoothing function, so it's not so jittery on the input. So bye-bye. I need 100% of my value, not 50% of my value. But now here's the problem. We come over and we look at the real-time data, and it's just jumping around like mad. 4 volts, 5 volts, almost 7, 4.5, 14, 3.2, 2.5, 4.2. I mean, the amps are pretty solid, 3.4-ish, 3.5-ish, even though we're actually at 4.11. I think that's just a calibration issue. But this is a stability issue. Oh, good, we're back up to 12 volts. So this is all over the place. And I need to do, oh, that's good, 1,331 volts. Need to do some research on stabilizing the input readings, or perhaps reading them properly. I mean, the mirror code to read these two different things from ADC0 and ADC1. One of them is highly unstable, and the other one is, yeah, roughly unstable. So, time for more research. Just to wrap this video up, because I'm not really making any progress, because of all the surgery I've done on the board and the number of times I've heated the pins, there is a non-trivial chance that I've actually damaged that chip. So I'm going to take everything into account and redo the circuit board. And I've also, as a side effect, discovered some naivete of mine about what makes an accurate voltage measurement. And how do you measure an accurate voltage against a voltage that's not accurate? You can't do it. So this is going to cause even more changes to the board, and that's coming up in the next video. As you stare out on my beach, I would ask you to subscribe to my channel and click like on this video so YouTube thinks I'm worthy again, and I have so many people on my channel that they'll give me 10 cents a day in ad revenue. So I thank you for that.